In this video, we're going to look at how to subtract mixed numbers. And to do so, I'm going to show you the two methods, which are very similar to what we used in addition. The first method is where we keep the mixed numbers. So we have the problem 4 and 5/6 minus 1 and 1/3. Much like addition, I'm going to choose to write this vertically, so I can kind of work across the screen. It's a little bit simpler for me, and it may be so for you. So our first step is to change these so they have the same denominator. So we're going to keep the wholes the same, so that's the 4 and the 1, but the fraction 5/6 and the fraction 1/3 both need to have the same denominator. When we look at 3 and 6, the least common multiple or least common denominator would be a 6. So the 5/6 we're able to leave as 5/6. The 1/3 we're going to need to change to 2/6. And we need to recall that this is a subtraction problem. So very much like addition, I can subtract the fractions. 5/6 minus 2/6 leaves me with 3/6. 4 minus 1 is going to give me 3. So I can once again, much like addition, take the 3 and 3/6 and reduce it to 3 and 1/2, which is my final answer. Okay. So this method appears to work the same as with addition. Okay, there's one little complication which we're going to learn about in 2 slides. But before I get there, I want to show you the second method. So we're going to look at how to solve subtraction problems with mixed numbers by changing the mixed numbers to improper fractions. So once again, I'm going to write this vertically. So 4 and 5/6 minus 1 and 1/3. If I change these to improper fractions, 4 and 5/6 becomes 29/6. 1 and 1/3 will become 4/3. Then I need a common denominator, which in this case would once again be 6. So 29/6 remains 29/6. 4/3 becomes 8/3. Once again, I need to recall that this is a subtraction problem. So 29 minus 8 is 21, and the common denominator of 6 stays. But I need to go through the process of changing this into a mixed number. So 21/6 is going to be equivalent. Okay, 6 goes into 21 3 times. 3 times 6 is 18, so 21 minus 18 leaves me with 3/6, which then I can reduce to 3 and 1/2. You notice that once again I end up with the same answer. Okay, this process of changing to an improper fraction always works, whether it be for addition, subtraction, multiplication, or division. So that's one of the perks for the improper fraction. However, you will notice that this whole process here, whoops, wrong button. This whole process here is a little bit more time consuming than the process on the previous slide. Now let's look at another problem. 4 and 1/6 minus 2 and 2/3. Once again, if I write this vertically, okay, I'm going to go through the process of finding the common denominator, and I'm going to use the first method, the keeping them as mixed numbers. So it's going to be 2. Once again, the common denominator is 6. So 1/6 remains 1/6. 2/3 becomes 4/6. And I need to remind myself that this is indeed subtraction. Now the problem with this is when I look at the fractions, I have 1 here, and I'm trying to take away 4. Well, without going into negative numbers, which we haven't covered yet, there is no way of doing this, okay, as it is currently written. But there is a way. When I think about the 4 and 1/6, it is like I've got 4 pizzas, 4 full pizzas, And then I have another pizza that's divided into sixths. And I have one slice of that. But instead of writing it, since I can't do much with this 1/6, I can choose to come up here to take one of the wholes and divide that also into 6. So now I have 3 wholes. And then when I count the number of slices I have, considering I had this whole pie, I have 6 slices from here, in addition to the 1 slice I already had from here. So I can choose to rewrite that as 3 7/6. And then I can leave the 2 4/6, which once again I'm going to subtract. Now I've solved my problem. 7/6 minus 4/6 leaves me with 3/6. 3 minus 2 is 1. This will reduce to 1 1/2. So practically speaking, because up here it's not conducive to have to draw this out every single time, basically what I'm going to do is I'm going to borrow from the 4, I'm going to borrow 1 whole, which in this case I'm going to choose to add 6, which gives me 7. I choose to add 6 because it's divided into 6 pieces. So by borrowing the 1 from here, changing this to a 3, I'm not going to add 1 onto here, but I'm going to add 1 full value. 1 whole value, which in this case is 6. So I basically add what I have in the denominator. And then I'm able to go through the process of subtracting and getting to my answer. So this is a little bit more complicated. Whereas when I look to my second method, it's going to be the 4 1/6 minus 2 2/3. I change to the improper fraction, which in this case 4 1/6 becomes 25/6. The 2 2/3 becomes 8/3. I don't have a common denominator yet, which I need, so this becomes 25/6. The 8 3/3 becomes 16/3. I'm sorry, 16/6 because I changed the denominator. This is still a subtraction problem. 25 minus 16 is 9. I keep my common denominator of 6, which becomes 1 3/6, which becomes 1 1/2. So, this process is probably about the same difficulty as the method 1 that we had on the previous side, but what you will notice is that I did not need to worry about using that process of borrowing because it becomes a straight subtraction problem. 25 minus 16 gives me 9. I don't need to borrow at all. So in that way, the process is a little bit simpler because it's the same process. No matter what, you don't need to worry about the process of borrowing. However, the borrowing can probably be done a little bit more quickly. Let's go ahead and give you one more example. 9 1/3 minus 3 3/4. You may want to pause the video here to allow time for you to work out this answer. Okay, hopefully you paused the movie and had a chance to work this out. So let me show you what I came up with for an answer, and you can match up and see how closely your work followed. And as you look at my solutions, you will notice that I got the same answers at the very end. So no matter which method you choose, you should still end up with the same solutions. Method 1 is a little bit easier from a mathematical standpoint as far as from arithmetic, as long as you get the hang of this process of borrowing. Whereas method 2, the numbers get a little bit larger, so you have to be able to multiply things correctly, be able to subtract things correctly, and then change an improper fraction into a mixed number. So either method is valid, and hopefully you will learn one or possibly even both of them, and that will be helpful to you. Okay, good luck with subtracting mixed numbers.